Welcome dear students. Today we are going to discuss a very good problem which involves both physics and mathematics skills. So in this question I would request you to first try it yourself so that you can find the points where you are facing the difficulty and the doubts, and then you watch my solution so as to understand the solution better. So the question goes like this, that here is a compass which we all have used in our childhood in geometry box. So the question says, find the angle by which a pair of compass should be opened in order to have pivot P as elevated as possible when the compass is suspended from a string at one of its arm ends as shown. Assume both arms to be uniform rods of equal masses and equal lengths. So essentially you have to find this angle theta so that this pivot point P is at maximum height from the ground. Let us say this is the ground and this is the height of pivot PH. So you have to find for what angle theta this height is maximum. So let us see how to approach this question. Suppose this is the scenario and I am holding this compass in this position, okay, and this is the string with which its arm is tied. So what do you think will happen if I release this compass from this position? Let us see what will happen. The center of mass of this compass will be where? Somewhere in between these two arms. So let us say this is the center of this arm, this is the center of mass of this arm. That means the center of mass will be somewhere in between. Let us say here. So I am holding, then it is fine. But as I release, what will happen? This center will experience a force mg, where m is the mass of the compass, and because of this mg, this will experience a torque, so that this whole assembly will start rotating. Torque will be what? Tau will be mgr. Okay, so that means as I am releasing this, it starts rotating downward. That means the position is unstable. Why unstable? Because of this torque. So how can we make this torque zero? We can't change the mass, we can't change the gravity, but we can change the r. So it means r should be 0 for this assembly to be stable. That means this assembly must be rotated such that this point center of mass rotates and comes somewhere along the string. I mean, it should come along the string so that this r becomes 0 and then it will be a stable assembly. Okay, so our aim is to bring this center of mass of the assembly along the line of this string. Okay, this line of the string here. So how will you do it? For that we need to first find the center of mass of the compass. Let us see how. Suppose I am holding the assembly like this in such a way that the angle bisector of the arms is horizontal. Okay, so this string is vertical and this angle bisector is horizontal. Since it is angle bisector, so let us call this angle theta by 2 and this angle also theta by 2. Okay, now let us find out the center of mass of this system. Suppose this is the center of mass of upper rod and this is the center of mass of lower rod. That means their center of mass will lie at this point, at the intersection of the bisector and the midpoint of this line. Let us call this center of mass C. Okay, and this pivot point let us call P. Okay, and this suspension point we call it A. Fine. Now what is happening here? Suppose I drop a perpendicular from this one here, then what do you see? This is A, the point of suspension, and this is the center of mass. So this is the distance AC, and this distance was responsible for I mean, this horizontal distance was responsible for rotating it as it was giving the torque. So, in order to bring this C on this line, this vertical line, as we have discussed that for equilibrium, the center of mass should be along the vertical through the string. So, this C should come somewhere here. For that, this should be rotated by how much? Let us say alpha. Okay, that means if you have to rotate this line AC by alpha, and also I have locked this, suppose I have locked this compass with the spread angle theta. Okay, this angle can't change now, it is fixed. So this whole is acting as a rigid body. This whole assembly is acting as a rigid body. If we have to rotate the center of the line AC, which is the from point of suspension to C, then we will have to rotate the whole assembly. Okay, so if this line AC is rotating by alpha, this rod will also be rotating by alpha, and the lower one will also be rotating by alpha. So let us focus our attention on the rod, upper rod AP only. Okay, let us see. Initially when I was holding, the rod was inclined like this, and when I rotated it such that the center of mass came along with came vertically in alignment with the string, then what happened? Then since the AC line rotated by alpha, this AP will also rotate by alpha. So earlier P was here, finally P came here in the stable position. In this situation, the compass is stable. Okay, now as we have seen how much, by how much angle we have to rotate. You see this angle is what? This angle is alpha. So this rod will also have rotated by alpha. So this angle is alpha. Now you see here, what is this total angle? This total angle will be what? This angle is theta by 2. So this total angle will be pi by 2 minus theta by 2. Okay. So same here, if this is the vertical line, then what we can say about this angle? This total angle will be pi by 2 minus theta by 2. Okay, total angle is this, and this center, I mean the angle in between is alpha. So what remains here? This angle will be what? It will be pi by 2 minus theta by 2 minus alpha. Okay, a bit of trigonometry involved in this question. So this is the scenario. Now what we can do, you see from this triangle, this second figure, if we call this point of intersection of the angle bisector and the vertical line along the string, if we call this point as M, then from triangle AMC, what can you say? Tan alpha is what? Tan alpha is what? Tan alpha will be MC upon AM. Now what can you say about MC? Whole MP is what? L cos theta by 2, and we also know if this is the center, that means this length was how much? L by 2, and this length also was L by 2. Okay, so this PC and CM both are equal, and both are what? L by 2 cos theta by 2. That means you can say MC is what? MC is L by 2 cos theta by 2. Okay, simple trigonometry is there. And what about AM? This AM, look from this triangle, this whole length is L, AP, and AP sin theta by 2 is the AM. So AM is what? L sin theta by 2, isn't it? So what we can say? The tan alpha is 1 by 2 cot theta by 2. Cot theta by 2. This is an important equation. Let us call it as A. We got a relation between alpha and theta. Okay, alpha is the angle by which we needed to rotate the assembly, and theta is the angle by which we have locked the compass. Okay, so now here you see tan alpha we got this one, and here see. So also now let us talk about the elevation. This point is fixed A. I mean the A is locked over here, so A is fixed. So suppose we draw horizontal line from A, then, and this is the final position of the pivot when the assembly is stable, and this is H. Okay. So what do you think? For maximum elevation of P, H should be minimum, isn't it? Because this upper point is fixed. So as you take P up over and above, H will decrease. So maximum elevation of P will be when H will be minima. So we have to find H minima. Okay. What is H from angle over here? You see, if AP is L, then H is what? H is L, this one, L cos of pi by 2 minus theta by 2 minus alpha. Okay, that means H is nothing but L sin theta by 2 plus alpha. Theta by 2 plus alpha. This is equation B. Now you see, we have got H as a function of theta and alpha. That means, and alpha we have got as a function of theta. That means we have got H as a function of theta. Now we will simply differentiate H with respect to theta and equate to 0 to get our answer. Let us see how. Let us write once again. H is what? H is L sin theta by 2 plus alpha. L sin theta by 2 plus alpha. Okay. And tan theta is what? Tan alpha is what? Tan alpha is half cot theta by 2. Half cot theta by 2. Okay. Now you just need to differentiate it. dH by d theta will be what? Here also see a mathematics trick is involved. Don't go in the details of alpha and theta relation. Simply just stick to your aim, and you need to equate dH by d theta is equal to 0. Do we need to check for d square h by d theta square greater than or equal to or less than 0? Do we need to check this for maximum minima? No, we do not need to check. Why? Because apply some common sense. Suppose this is the string and take two scenarios. In one scenario, what you do, you just fold this compass by, let this angle be 0 degree. 0 degree. Then where is the pivot P? Here. In the other case, suppose I open the compass fully. Then what will happen? This is one arm. This is the pivot P, and this is the other arm. So again this is at 180 degree. So here what is the value of H over here? H equal to simply L. L is the length of one arm. Here also H is what? H is the simply L. H is the depth of P from the string suspension point. So in both these cases H is equal to L, and also you can see this rod can move about this point only. That means the point P can move on a circle only. At any point on the circle, its depth from this point will be less than L only. Okay, for any angle between 0 to 180 degree. That means H will always have a minima only. Maxima of H is H equal to L only, which happens at the opening angle being 0 degree or 180 degree. Okay, so we need not bother about this thing. We just need to find dH by d theta equal to 0 and find the answer. So let us see what is dH by d theta equal to 0. dH by d theta, you get what? dH by d theta is L cos of theta by 2 plus alpha times what? 1 by 2 plus d alpha by d theta, isn't it? So if this is to 0, then this has to be 0. That means d alpha by d theta should be what? D alpha by d theta needs to be minus half. Let us call this equation C. Okay, now come here, differentiate this one. Okay, this will be what? Different sec square alpha d alpha by d theta, and here what? Half minus cos x square theta by 2 times half. Okay, d alpha by d theta should be what? Minus half. So put it here, you get what? You get sec square alpha is equal to half of cos x square theta by 2, isn't it? This is what you got. Now sec square alpha, what we can write? We can write it simple, 1 plus tan square alpha is equal to half of cos x square theta by 2. Okay, now tan alpha is what? Tan alpha is, here you see, half cot theta by 2, half cot theta by 2. So put it over here, you get what? 1 plus 1 by 4 cot square theta by 2 is equal to 1 by 2 cosec square theta by 2. Okay, now it's very easy. You simply need to multiply throughout by sine square theta by 2. So what you get? You get sine square theta by 2, sine square theta by 2, and if you use cos square theta by 2 is equal to 1 minus sine square theta by 2, you will get simple on the RHS what you get? 3 by 4, and this side you get what? Half, because it is done. 1 upon 2 minus 1 upon 4, that is 1 upon 4. So by this what you get? You get sine square theta by 2 is what? Sine square theta by 2 is 1 by 3. Okay, so sine theta by 2 is what? Sine theta by 2 is 1 by root 3. Okay, that means theta is what? Theta is the angle, the opening angle of compass is what? 2 sine inverse of 1 by root 3. This is the angle by which the compass should be opened so that the pivot point is at the maximum height. So you see how mathematics and physics merge in this question. So I hope you liked the solution, and if you have any questions, any doubts in this, please feel free to mention in the comments. I'll be happy to respond. Thank you.